Happy World Oceans Day, a day to celebrate our oceans and raise awareness about the vital importance to our planet. So please take care of them. You know, the ocean can be comforting for many, but our homes are also comforting. Well, they're supposed to be. Today, we're going to discuss how high-performance HVAC systems impact energy efficiency, indoor air quality, and comfort. We're specifically going to look at Rheia, a novel HVAC engineered distribution system designed to meet today's and tomorrow's energy codes, reduce builders' cycle time, and cost-effectively move ducts to conditioned space. This system is already in use by production builders like Lennar, Pulte, Beazer, Taylor Morrison, and D.R. Horton because it reduces cooling tonnage. It increases the opportunity to access federal and state tax credits and local incentives, and it reduces waste. Now, here to introduce us to this new system is Alan Lang. He's a partner and CEO of Rheia LLC. Alan has spent the last 35 years in the construction and residential home building industry in various senior management and executive roles. He recently retired from national builder Taylor Morrison, where he was the executive vice president of home building. Now, prior to Taylor Morrison, Alan was the CEO of Orleans Homes, where he led the turnaround and eventual sale of Orleans to Taylor Morrison and Lennar. He also spent 15 years at Pulte Homes as National Vice President of Operations and Area President for Pulte Building Systems. Alan currently serves on the North American board of Rockwool International, which is a global insulation manufacturer based in Denmark. Now, the Thought Leader webinars are part of our larger Housing 2.0 program. The content for that program is based largely on Sam Rashkin's latest book, Housing 2.0, A Disruption Survival Guide. Now, that program empowers building professionals to design and construct higher performance, healthier, more sustainable homes at a fraction of the cost. You can learn more about that program by visiting www.greenbuildermedia.com/housing-2.0. Now, I need to comfort our sponsors by telling you about them. The first is Mitsubishi Electric. Mitsubishi Electric promotes sustainable building through the electrification of residential and commercial heating and cooling products. Their mission is to advance technologies that reduce waste output, promote sustainable resource cycles while increasing energy efficiency and eliminating dependence on fossil fuels. Next is Westlake Royal Building Products. They are the North American leader in the innovation, design, and production of a broad and diverse range of exterior and interior building products, including siding and accessories, trim and moldings, roofing, stone, windows, and outdoor living. For more than 50 years, Westlake Royal Building Products has manufactured high-quality, low-maintenance products to meet the specifications and needs of building professionals, homeowners, architects, engineers, and distributors while providing stunning curb appeal with an unmatched array of colors, styles, and accessories. For more information, please visit westlakeroyalbuildingproducts.com. Schneider Electric is driving the digital transformation of modern homes with smart and sustainable energy solutions for ultimate comfort and energy efficiency. Their connected home ecosystem of smart energy management solutions provides digital control of energy use throughout a home, from the grid via their smart electrical panel to their connected wiring devices. This grid-to-plug solution makes it significantly easier to create smart, solar power, and backup power-ready homes, both now and in the future. And our newest sponsor is Beko. They exist to empower new generations of homeowners to live healthier lives on a healthier planet. They created the industry's first Healthy Kitchen Council to help guide product innovations. And they are one of the most sustainable brands in the world. And that claim is backed by Beko's parent company becoming carbon neutral in global production operations 3 years ago. Plus, they're the only home appliances brand to receive Energy Star designation every year they've operated in the United States. That's 6 years in a row and counting. Now, if you have any questions for our guest, please enter them into the questions box, which is found in the GoToWebinar control panel. I'll review those questions and pose those to Alan after his presentation. All right, Alan, welcome to the webinar series.
Thanks, Mike. And Mary, thank you for setting this up. Great introduction. You covered a good part of my presentation, so thank you. Glad to be here today and look forward to questions at the end of this. Mary, do you want to go to the next slide? Hello.
Uh-oh. Hold on just a second here, Alan.
Yeah, it's, there we go.
There we go.
My apologies.
No problem. So Mike had touched on this, but we're an engineered supply-side distribution system that improves homeowner comfort, reduces installation time for the trade, and it's designed to meet today's and tomorrow's energy codes, and reduces builder cycle time. There's other benefits, but that's kind of the core of it. So maybe I'll talk a little bit about the background. Next slide. So this started with my partners at Ibicus back in about 2016, maybe even before that. There was some related research. DOE was very involved early on. Carrier spent some time with us from 2017 to 19, and it involved as a bunch of pilot homes and testing. And ultimately, we built. I joined the company in 2019. I've been retired, as was mentioned earlier, and my partners talked me into moving to Pittsburgh for a few months to get a better understanding of Rheia, and then to develop strategy to bring it to market. So we raised some capital in 2020, just before COVID, and then we began the production for our tooling during that year. Obviously, it was an interesting time to be starting a company. And then we are fully in production now. The last 18 to 20 months, we've been working across the country and installed thousands of homes successfully. And along the bottom, we did something unusual. We invited those eight builders to become investors in the company. And they're minority investors, but nonetheless, their investment levels could be as little as $200,000 or $300,000 and as much as several million, depending on the builder. And our logic there was that they would be good investors, but furthermore, they would be more invested in innovation and change, and we'd be able to get their mind space that was going to be required to create the kind of transformation we're enjoying. And so far, so good. They've been really good investors. We've got about 40 other investors that range from individuals to companies. Next slide. So what is it? Be on the right one now. One more. Perfect. We're headquartered in Phoenix. Obviously, I'm the CEO. We've developed a group of about 20 people that range in skill set from HVAC designers to product development experts to finance, and then the biggest part of the organization is a field technical group that is just distributed around the country that work with the trades and the builders locally to identify the opportunity, manage the change process, and most importantly, train and certify the HVAC companies, their individual crews, and provide technical support for them. We're really excited about everything we're doing. We've also partnered with HVAC design firms around the country. There's about 10 of them that we work with actively. In fact, as I sit here today, we've got 5 members in from MyTech from all over the globe that are going through 2 weeks, spending 2 weeks with us to get detailed training. So that's who we are. Next. When we step back to 2015, 16, 17, the underlying thesis for Rheia was, how do you get in front of the ever-changing building and energy codes that seem to be rolling from west to east? So California, Oregon, Washington, with some exceptions. Minnesota's got an aggressive energy code as well. But how do you get in front of that? And one of the hallmarks of all of them was either rewards or incentives or penalties if the ducts were outside the thermal envelope of the home. And that kind of gave birth to this notion of a 3 and 4 inch diameter ducts that could be efficiently and easily routed inside the thermal envelope of the home and get in front of the code changes proactively. And that's been generally the path we've been on. And for example, I live in Phoenix, and here with a huge cooling loads, the insulated ducts are 14, 16 inches around. So moving them out of the attic and into the conditioned space architecturally really challenging to do. We can do that very efficiently, either route the 3 inch ducts in 2x4 walls or in very discrete, small 6 to 8 inch drops in ceilings and chases. when in homes that are 9-foot, 10-foot plates, they've become very discreet and not nearly as much architectural interference. So that's kind of the why part of the original investment and the activity. Next. So some of the features, as I mentioned, they're small diameter ducts. It's a low velocity system. We sometimes get compared to Detson or Unico, which are high velocity. Ours is low velocity, and it works with any air handler, Carrier, Lennox, Steichen, Trane, York, any of them. We use a home run system, kind of like the old PEX plumbing system. So everything is dedicated from a manifold with direct duct distribution to the room. Everything is snap fit connections. They're basically a wire cutter, utility knife, and a drill, and you can install the whole system. And we've seen up to 50% savings in labor, which in today's environment has been really helpful to us and everybody else. And every diffuser has a damper. So we've got a really good strategy for managing comfort in the home, and we'll go get to the details of that in a second. And the whole system is only 16 SKUs. So conventional systems, we'll see distributors and contractors, they'll have 2,500 to 5,000 SKUs to manage all the different combinations of boots and products and dampers and diffusers. And we're managed this whole system with 16 of them. Next. So the value that we present to both builders and contractors is cost effectively moves the ducts into conditioned space. And we've seen, as I mentioned, aggressive codes that either reward you. For example, in Minnesota, if the ducts are outside the conditioned space, you've got to do a duct leakage test that's really hard to pass in that state. And they defaulted in many cases to using products like AeroSeal, which were expensive, and we've been able to work collaboratively with the architects and engineers that the builders get all the ducts in conditioned space and relieve the requirement for doing duct testing, leakage testing, and therefore all the cost of either mastic and glue and tape, or in some cases AeroSeal. So that has been a really positive financial outcome in a better, higher performing home. Generally, we're picking up 2 to 3 HERS points by moving the ducts into conditioned space. Generally, depending on where you are in the country, you're going to get half to a full ton of tonnage in reduction of the sizing. There's federal 45L credits that singularly using Rheia is not necessarily going to make you qualify for, but it's foundational to getting there. In some states, there's pretty aggressive tax credits as well, and even in some municipal incentives as well. We're taking generally a day out of the production cycle time, which obviously is important. We've had very few callbacks, and because of the mixing of the air, if you imagine having 3 or 4 sources of air in a master bedroom versus 1 or 2, and they're distributed between the high side walls and the floor, we get much better air mixing. We got some really good data on comfort we'll get to in a minute. And lastly, we think we have about 90% job site reduction in waste. So depending on where you sit in an organization with what we see with ESG initiatives, obviously your less waste is good, and obviously the cost of that as well. So we've had a great waste story. Next. So in terms of the product, the duct it's actually gray in color versus the picture on the slide here, but it is a 30-year-old duct that's been around a very long time, made by Thermoflex. It's 3 and 4 inches, and it's got a wire helix and a very durable fabric exterior. It's 181 rated. It's a Class A duct. It's been, as I said, been around for a long time. Our component parts, the 2 threaded in pieces you see there are the ferrule, so that threads onto the duct and air seals. In fact, when you put it on, if you put it on just by hand tight, you can't get it off. So that when we're demonstrating it, we've always got to tell people, if you really wrench down on that, it's going to be there until you cut it off. And then the piece in between is a coupler. So that allows us to splice lengths of duct. The duct comes in 50-foot lengths, so there's not a lot of splicing, but the connectors all pass a new UL standard called 181C, which is a really high standard to get over. So we've never failed a duct leakage test in the history of the company at the Energy Star thresholds. The snap fit, twist on, twist off, it's oral. So when it's seated, there's a click. So the installers can really learn it very quickly, and it's hard to get it wrong. So it seats, clicks, and you're done with it. And then we've got patents on the majority of the system. We got systems patent and we got component patents as well. Next. And then you can see what I described there. Now we've introduced a coupler to an elbow, a couple of elbows, depending on what the requirements are. And on the right side are the boots. So we've got on the top a high sidewall, which would sit 5 or 7 inches from the top of the wall. We have a mounting bracket that you can use to center it or place it, or you can use, as you can see the holes, you can mount it directly to the top plates. Pass-through boot is if there's a bulkhead, same thing. The ceiling boot is obviously for the diffusers, and then on the manifold box, there's an inside and an outside that clamps together that you attach the duct to. Next. So the manifold is kind of the centerpiece of the system. It sits on top of the air handler. Our design software generates a layout and a template that as you can see, the tradesman there is cutting them. We also will, we have a sheet metal version of this, although the ductboard seems to be preferred. The contractor builds it. A lot of them are starting to do fabricating in their shops and taking it out to the home. The shop drawing, as I said, comes from the design software and the designer. That's 1-inch ductboard. And we provide a whole guideline, and so we've got instructional videos on our website on how to do this. And then, as I mentioned earlier, the fittings snap together by hand. Next. From the diffusers, the high sidewall on the left, and these can be painted. You'll go into a lot of model homes of ours around the country, and they'll actually be painted to the color of the wall. And on the right is the ceiling diffuser. We've got a couple versions of this. We have a smaller diameter one for northern climates and a larger, the one you see here, for southern climates. And again, all of them are paint grade, and each one of the diffusers has got a 5-position damper inside them. Next. So here's some pictures of interiors of homes, and you'll see we've integrated them in with the lighting diagrams, and they're pretty discreet. We as builders will walk in and stare at the ceiling and think that it might be a little busy, but actually we've never had a single comment from a homeowner. Once you furnish a home and move into it, it just seems to disappear into the wall. And relative to if you're living in the Midwest, you got brown, ugly floor diffusers on the floor underneath the curtains and the couch, or in the southern climates, larger metal diffusers that are not conveniently placed. The one at the far right picture is actually a Southern California home, and it's got a glazed curtain wall. So there's actually got huge heat gains in that home that resulted in those 3 diffusers above the door. We're doing some consumer research now to come up with combination diffusers, so there'd be a little more of a commercial linear look. But we've had good feedback on the use of these ones already. Next. I think I'm going to assume that most of the folks on the call are familiar with the manual J, S, and D process. And if you're not, I'll go a little bit slower. But basically, step 1 for us, and it's the same as a conventional process, is a load calculation that generates targeted airflows. These are required by code. The manual S takes those loads and then provides a database of equipment that you can select, the air handlers, compressors, or package units, whatever it is you're choosing. And then manual D is the duct design system. In the conventional system, it's probably the weakest link. In our system, it's what's different. There's a lot of the algorithms and the intellectual property of the company is founded in the algorithms of airflows over length of duct. That took a couple of years of testing to get where we could program it and ensure it works. And then at the end of this, we have a Verify app that operates on a phone. So the contractor is trained, and they go into a home with a hood capture. They pull up the design on the phone. They capture the airflows out of each diffuser in the home. Takes about 30 minutes. They enter the airflows into the app, and they hit verify. It runs against the design background, and it'll generally suggest you go back and change 4 or 5 diffusers in the home from position 3 to position 5. We then guarantee that home is going to operate at the design airflows. So if that second bedroom called for 90 CFMs of air, we're guaranteeing that it's going to be within 10% of those airflows. And then lastly, there's a report that can be generated and left with the home or put in a binder for customer service purposes. So again, somewhat of a traditional process with a little more emphasis on the home run duct system, and guaranteeing that the airflows are going to be per design, and then verified that they are kind of a commercial balancing and commissioning application. Next. So we're operating, these slides, we're always updating them, but in multiple markets. The gray is what we're moving into production now, and the blue is where we're in full-blown production. And our general market entry strategy is to partner with one of the investor builders or somebody else. You know, you'll see Shea and Fisher and Ashton Woods. There's a lot of American Homes for Rent is another one, that they're builder customers of ours. Generally, we're going to start with them. We're going to select a market and enter it, and then generally do some monitoring for performance and trade education. So this map's ever changing. We're heading into South Carolina here shortly. For example, next week we start there. We're going to be in Iowa in July with D.R. Horton. So check frequently in our website. You'll see if we're not in your state yet, we may be arriving soon. Next. So these are some data. Again, it's a little bit dated. Right now we're installing about 1,500 homes a month, and growing. Next. From a supply chain standpoint, which is obviously a popular topic with everybody today, our duct is manufactured in South Carolina by Thermaflex. They're adding new capacity, and some of that's going to be distributed to Houston and Phoenix over the balance of this year and early into next year. We're entertaining other suppliers, but they've been a really good partner. Right now, we're excited to get them from a freight standpoint a little bit further west. Our plastics partners, a company called Viking Plastics, they're based in upstate Pennsylvania, and most of our production to date has been there. It's shifting as we speak to a dedicated facility in Jeffersonville, Indiana, right outside Louisville. Up to this point in our history, we've been generally what we were making and shipping directly from our manufacturers. That's over the course of the next 18 months, we're going to be adding more distribution. We have a small distribution center here in our office in Phoenix. We're going to be adding a second one in Louisville. And then we'll add further injection molding capacity in the West. We suspect somewhere in the Salt Lake City, Nevada, Reno area by the end of the year. So robust supply chain. Our lead times today are 6 to 7 weeks. We've had really great stability in our pricing. We've had one price increase in our couple of years of commercial activity. So we've been blessed in that sense. Next. We get questions around this in static pressure and whether, how does that work in this system? And generally the manifold box is pressurized, and then we manage the static like you would any conventional system. And we test for static when we commission the home, and we've always been within ranges, manufacturer range for statics. We're advocates of central returns, or we don't insist on them, but we're advocates of them. I think the building science community is aligned around that as well. We do see the use of jumper ducts around master bedrooms. We also see use of transfer grills above secondary bedroom doors, but wherever we can influence it, we're suggesting central returns. And all that's in balance with airflows, right? We want to be able to relieve whatever we're putting into that room needs to be relieved to avoid static pressure. And we've seen good results with testing with that. And then balancing, obviously, with a damper at every boot that allows us to be precise with measurement and balancing. And that's kind of, if you thought about it from a technical standpoint, basically we're pressurizing a box within static ranges. We're relieving it through a return strategy that's certifying that the room CFMs at the end of the process are as per design. Next. Early on, we did a lot of monitoring of homes, and it would be for a variety of things. It could be comfort, it could be for temperature, relative humidity, dew points. The home in Pittsburgh, where a lot of this was originally conceived, we held for about 3 years, and we went through multiple variations of testing and sampling. We did 18 townhomes or 16 townhomes in the Maryland, DC area that we monitored for well over a year. We monitored a home in Florida for 6 months. We're monitoring homes in Phoenix now, and we monitored a home in Portland for a full year. We collected a lot of good data. I'll share some of it here in a second. And we've done less of it lately. We've gotten pretty confident with the results. Although recently we actually put a monitored home in Houston along the shipping channel, kind of right in the belly of the beast of humidity. And we've had the monitoring on for a couple of weeks, and so far so good. Next. So some of the results of that, if you were to measure comfort, by room to room, deltas in temperature and floor to floor. This particular chart's room to room, and it's both heating and cooling. And you can see, I'm not going to read it all to you, but we've had really tight banding of room to room temperatures. And in every case where we've been able to, we've either monitored a model or the same floor plan. Now, these are less than scientific when you're comparing two homes. There's so much dependent on people coming in and out of the house and where they put their set point for their thermostats. But we've had really good results. We haven't had a single comfort complaint in the 18 months we've been doing this. Next. So our typical introduction for anybody on the phone that would like to engage with us, this is our broad kind of roadmap. There's an introduction. It could be very similar to this. It's a very similar presentation on a Teams call with a builder and possibly their contractor. We have a design library that we would send you if you said, look, we're building 2,000 square foot box on box, 2 stories on basements. We'd send you 3 or 4 sample plans, and you can see where the duct routing and it is in those plans and get a sense of what it would look like in your plans. The builder's going to do some evaluation of it for fit, and then if it's a go, we would enter a design phase, and we would collect all the information. We'd introduce you to a third-party designer if you don't have one. If you do have one, we would work with them and train them if appropriate. Obviously, that is an intake on the construction documents, the specifications, who your energy rater is, who your trades are, and whatever anything else relevant. If there's rebates you're trying to get to, we'd like to understand what those goals are. That's going to take 2 or 3 weeks for us to get a design executed, and then there's obviously an iterative process when it is done to get everybody on the phone and say, okay, we think this is going to work, or there's a beam here we didn't understand or missed, and whatever adjustments and red lines need to be made. We would then do a pilot home typically. Now, if you're in a market where we're already active, then you can go see all this firsthand in a competitor's community. Everybody's really good about making those communities available. We might not do a pilot home if it's in a city like Denver or Minneapolis, where we've got dozens of homes going on every day. There'd be the Rheia installation. It would take a couple weeks after the pilot scheduled. There'd be a debrief, red lines, value engineering. If there's monitoring, it'd take us a few weeks to get to the end to get the verification done as the home is closed. And then we'd host a production and planning meeting that would look at which communities, what floor plans, and by way of example, where, the Pulte, where we're working with them in several cities in the upper Midwest and Mid-Atlantic, where they build 2 townhome plans, and they're pretty much unchanged, but for climate zone from across 7 or 8 markets. So we're always looking for leverage in our design efforts where we can reuse the plans. If that doesn't exist, then we enter into a phase where we're designing for each community. Next. So what we've learned and what we ask for in terms of the builder's engagement, there's obviously some attendance in these meetings, getting the floor plans to us on a timely basis. If it's an I-joist floor system and there's going to be cutouts, then obviously there's a little more involvement. We've done lots of them and it works, and conventional systems are required as well. Working with us to finalize the designs, and then if there's any adjustments. So that from the design and the architecture and the interplay, that's what we ask for. Same purchasing, again, be involved right from the beginning. Introduce us to the trades, stay involved with the trades. Develop the scopes of work based on our template. We provide builders a drafted, started scope of work that they can integrate into their documents. Help us, if needed, set up Rheia product distribution. We typically sell contractors, big contractors directly, but we've got distribution in every market. Our strong preference is direct, if they're big enough to take truckload shipments and they've got good credit. And then obviously the integration into our warranty in the event it's needed. From a construction standpoint, obviously now we're getting into the codes and permitting. We're batting 1,000, although some municipalities are a little more challenging to get over the goal line, but we've never been in a situation where we haven't been able to get there, with the exception of North Carolina, where they do not allow for uninsulated ducts inside a floor system. So we're in the middle of engaging in their code approval process. It'll be next year before we're through it. Everywhere else, including California, we're approved. Any framing changes that need to be made need to be coordinated. And then we hold a field training session with the contractors and the superintendents to make sure that we've got a handout on the QA side. If you're a superintendent and you're walking a home at mechanical frame complete stage, you know what to look for with our product. Are the ducts pulled tight? Is there elbows where they're needed? There's no pinches or kinks, very similar to a traditional duct inspection. We've got a whole set of sales support tools that we get with the sales teams, and we're needed if they want to put a small display in their quality wall and their models. We've got a package that goes with that, and we provide them marketing materials as well. Next. So if you wanted to get started, first thing I'd do that's not on the slide is I'd encourage you to go to our website and watch. We've got some really good video content of the different components of the home or the process, the design side, the installation, the training. And we got training guides. We got videos on the commissioning. So it's a great source of education. If you got through that and you said, yeah, we'd like to try this, obviously reach out to us, but these are some of the pre-work that we would need you to think through. So community name and the address, the target and type of plans, how many plans, what types are they, when would it start, when would production start. As I said, our lead times are manageable, but getting in front of the supply chain challenges today is just the responsible thing to do. So some scheduling and planning, all the contractor information, and all the design energy raters, all those things. And then we do our best to integrate with the lighting layout, so we've got a nice clean ceiling. So that these are the formats we like those things in. Next. And that is the highlight reel. I try to get through that pretty quickly with the hopes that there's some questions, and if there is, Mike, I'm happy to take them.
Yes, there are some questions, and I did put into the chat box there to please send in your questions now, because we'll be taking them over the next half hour or so, if you have them. So Question came in about from Drew about you had a slide about how the kind of the process of it works, and you talked about balancing and that sort of thing, static pressure. But he had a couple questions. One was, do the small ducts need higher pressure for the same CFM?
No. So it's using the builder grade air handlers, and the manifold box pressurizes. I'm going to give you some general numbers. For a 3-inch duct, we have 3 and 4 inch, but a 3-inch duct, if you're 5 feet from the manifold, you may get as high as 45 CFMs. If you're 40 feet from the manifold, that CFM might be 31. And that's part of the algorithm and the design software that allows us to say that room that is 40 feet away needs 120 CFMs of air. We know it's 40 feet. It assumes some sweep and some components. And it'll specify the number of ducts to be in that room, and then the dampering is the fine tuning to deliver that exact 120 CFMs. So no additional pressure, no additional equipment. And like any HVAC system, our system works better with variable speed fans, but it works with the basic builder grade, apartment grade air handler.
A question from our friend Fernando. Is the system limited to cavity walls?
No, if I understand the question. So we're running anywhere in the conditioned home. Generally, we are running vertically in 2x4 or 2x6 stud walls, and just chasing all the way up vertically. We also go horizontally in floor systems. So it could be open wood truss, it could be I-joist. Periodically, we'll drop ceilings or drop chases in laundry rooms or closets or discrete areas in the home to route ducts around. We see some interesting things in some of what we do, but so we can run them pretty much anywhere. Air sealing is a critical part of this, right? If you're gonna have a chase against the attic in a hot, humid climate, we've got some suggested construction details that we like followed. To make sure there's air sealing and no moist air getting into the chases. But we can run the ducts just about anywhere. We're not at batting 1,000 with getting every duct in conditioned space, but we certainly aspire to.
Okay.
I don't know what happened there. My computer's blinking on me.
Maybe you're getting low battery, but we still see you. We still hear you.
Yeah, it's plugged in. Sorry.
All right, that's fine. That's fine. Another question came from Drew. What are the HERS savings based on? Is that just compared to a traditional system, or you talked about 2 to 3 points there?
Yeah, some of it is the HERS rating outcome of moving the ducts into conditioned space. Some of that is the sizing of the equipment that also corresponds with, for example, in a market like Phoenix, everything, air handlers and ducts are in the attic. So there's a HERS pickup when you move them out of the attic and put them into conditioned space. If you want to get my email information out, I can have one of my engineers respond with a more technical answer, but it's generally in the HERS performance, both the prescriptive modeling and then the testing on site is we're seeing 2 to 3 points on average.
Okay. And yeah, you mentioned email. We had a request come in for the website and the email address because that wasn't something that was posted, and so if we could share that with our audience, that would be really helpful.
Yeah, my name is Alan Lang, but my email is alang, L-A-I-N-G, at rheicomfort.com. And our website is www.rheicomfort.com.
Okay. I just put the web link into the chat for everybody. I wanted to get to a couple other questions that we had. Again, from our friend Fernando. Can these ducts be routed through the cavities of concrete masonry units? He builds in the Caribbean. And so CMU is much more common there?
They would have to be inside the thermal envelope of the house. I'm trying to imagine what that looks like. If they were on the thermal side of the masonry, yes. If they weren't, I would say no.
Okay. And can you talk a little bit about the maintenance requirements? As an example, just one example, how do you clean these ducts once they're installed?
You can conventionally clean them. So they're the same method as you would use traditionally. You can vacuum them, or you can, I forget the term that you would use, but so you can, however you're cleaning ducts today, you would clean these. From a maintenance standpoint, there really isn't any. You know, it's once home is commissioned, or we hope. Now, consumers, if they want to pull the register grills off, they're obviously they can reach the dampers and move them around, and that's why we want to have a balancing report. If there is a comfort complaint, we can go back and set the house to its original verified position, and then take some readings and measurement. So no extraordinary maintenance required. Change filters like you'd normally do, and it works just fine.
Okay. We did have a question about a specific slide. So Mary, if you could pull up, it was the slide about the process. It was right before the monitoring program slide. There was a question about, yeah, just go back a little farther. Keep going, Mary. Good job. Yep, right there. There you go. Very good. So the question came in, what is better missing as shown on your slide? So the question was a little unclear, and so I thought, well, if we pull up the slide, maybe I could get a chance to look at it. But I don't see what's being referred to here, so hopefully.
Do you want to read? Some of the questions are pretty common. Do you want to just read it to me as you got it, and I'll see if I can understand what they're trying to ask?
Well, it says, what is better, quote, missing, quote, unquote, as shown on your slide? So again, I'm a little bit of a loss for that one.
Okay.
But I had a question for you, Alan,
Sure.
and that was, talk to me about what it was like getting the conversations going with some of these builders. You know, how receptive were they initially?
You know, I'll take it in two ways, Mike. I think I'm a career home builder. Obviously, I've been an executive at big public companies like Pulte and Taylor Morrison. Now, within my career at Pulte specifically, I ran $1 billion trade business. So I've kind of rare in that I've been on the supply side, contractor side. So I know a lot of these folks, the C-level folks around the other big builders. So when it came to the first discussion was around investment. And that was pretty singular topic to say, this industry has suffered miserably with a lack of productivity for decades and very limited innovation. You know, nail guns and roof trusses or wall panels are the innovations that are actually commercially available in the industry. I said, look, if we're going to solve the productivity challenges, we've got to narrow it down to one vertical trade at a time. You know, they invested in the Building Talent Foundation to try and address the labor issues, and it was attaching to some of that momentum and saying, what if we could take one trade vertical and create technology that did everything we've talked about, but really initially said really helped with the labor issue. We can take a younger, lower skilled entry-level person and train them how to do this. Within 45 days, they're really good at doing it. It takes us 45 minutes to train a crew initially. And by the fifth time they do it, they're getting really good at it. And we've seen 30 to 50% labor improvement. So the thesis for the investment was really around labor. And I was talking to the CEOs of these companies. Most of them got it pretty well. We had a really good introductory video that explained it. But we had the home in Pittsburgh, and the recently retired COO at Toll Brothers. As soon as he walked in the house, 3 minutes into it, he says, well, of course, this is what we should be doing, right? He had to see it. And when he did, he went, well, this makes perfect sense. So we had a really good response at the C level around the notion that we needed a higher performing system in general, but we really wanted to attack this labor issue. In the day-to-day world of VPs of construction, VPs of purchasing, sales VPs and builders and trades, we've had largely really positive responses. We have a patient approach with it. We've got data on our side and performance on our side, and we've had a really good response. Some builders want to go a lot faster than others. There's some other builders that are watching. They're fast followers, not necessarily leaders, but generally speaking, we've had a really positive response. I think one of the challenges we've all enjoyed the last 18 months is just originally was the mind space with all the supply chain problems to even think about doing something different. What's been a bit of a catalyst for us the last several months is there's a really meaningful shortage of insulated flex duct. So the builders that were maybe thinking about it kind of stepped to us because they couldn't get houses built conventionally. And we've had great success onboarding them. Obviously, we don't have the capacity to take up the shortfall in insulated duct everywhere. I'd say the greatest resistance has been at a VP or owner of a trade company who's been doing something for 30 years. I've had a lot of people put their hands on their hips and say, yeah, you don't understand static pressure, you don't understand airflows. And then we'll go through this process with them where we do a pilot home and they look over our shoulders when we do the duct leakage test and the static pressure test. And they go, well, I'll be damned, I didn't think this was going to work, but tough to argue with the data. So we've had good conversions with 98% of the trades we engage with. So we've had, it's worked, but we've had a positive response. Some of it is just change in general. Wouldn't matter what we showed up to talk about, it would be problematic. Some of it has just been, in some cases, a really responsible set of questions that are fair questions to be asked of us, and we owe them a really good response, which we've been able to do.
Gotcha. We figured out, a couple attendees helped us with it. So the room CFMs portion of this slide, the second sentence, it says that Rheia provides better missing instead of mixing, I think is the guess. It's just a simple typo, I think, is what we're finding.
Yeah, it is. Yeah. Someone's got a sharp pilot.
Yeah.
So if you thought about that, so if you went into, as I've mentioned earlier, a great room in a home or a kitchen area, we may have 4 or 5 diffusers in that room. There could be 3 high side wall, 1 on the floor, and 1 on the low wall. And the outcome is we get much better air mixing. So that those ceiling diffusers are going to throw air 6 feet in every direction, hit the walls, and roll down the walls. The high sidewall is going to blow 12 feet. We got a huge throw in them. So we're throwing from the interior of the house to the exterior. So all that air mixing is what creates comfort, and it lessens the stratification stack effect of air in the room, if that makes sense.
Okay. Yeah, it does. I did have a question from Dan. He wanted to know if you have measured the dew points within some of these building cavities to assure that there's not going to be condensation on the ductwork during cooling season.
We sure have. We had a home in Orlando that we held from April through to October. So our view of it is the greatest risk is in shoulder seasons where the system, humidity is growing, but the system isn't running as much because the loads aren't as great. And we built chases against the attic purposely. And then we had ducts in the floor systems as well. And we had sensors in the home, but we were even more basic. We put trail cameras into the chases so we could sit here in Phoenix and every day look at the performance of the ducts. And our first effort, we did get some moisture on a duct in an attic. And this is an interesting story. That home was built. We were supposed to go there to train the crews to install it the week COVID travel started. So we actually trained the crews from our garage here, our workshop. And what we didn't realize in the pictures they sent us, they'd used OSB as the sealing of the chase at the attic level, and the only sealant they used on the seams was pink insulation. So we got warm air infiltrating into that cavity. So we went back and we foam sprayed sealed the chase from the attic side, and we had no issues. So we pay attention to the floor cavities. We've got that's what we're doing. We're doing in Houston, which we think is, along with Miami, pretty much the most extreme environment. And there's been a lot of failures in the industry. And I think we're on our 10th day of monitoring a home we built in Houston and right in the shipping channel, and so far so good.
Gotcha. Final call to our audience for questions. If you have any, please send them in. I get one more, and I'm curious as to your kind of take on this. Some of the elements of what I'm seeing and hearing here remind me of the Unico system. Are you familiar with that company or what they do? And I mean, can you talk a little bit about, is it a similar situation? Are there differences?
Yeah, they're very different. So I'd throw Detson and Unico into this. Detson's the Quebec-based company. The biggest difference is their system requires you buy their air handlers. And one, they're very expensive, and they operate at high velocity, high static, high velocity. We don't. You can use the Lennox carrier or Train. It doesn't matter. Our system works with any of them, and it doesn't operate at high pressure or high static. Oddly enough, we're entering the Toronto market, and part of what's taking us there, I'm Canadian, so that's part of it. But the bigger part is that the companies that are in that high velocity space are failing. They're having equipment failures. So everybody loves the idea of the small diameter ducts and the easily routing and keeping conditioned space, but they're having equipment problems. And the challenge there is you've got to continue to buy their equipment. You can't swap out. If you're upset with Lennox here, you can switch Carrier, Train, or Goodman. That's not possible to do when you've got that system installed. So similar in concept in terms of an efficient way to route ducts inside a conditioned space. At the cost level and the equipment level, very, very different.
Gotcha. Okay. Another question from the audience. What's the approximate fan operating cost on an annual basis per 1,000 CFM? Do you have any?
Yeah, I don't know that. Okay. If they email me, and so I got their contact information, one of our engineers can respond to them.
Okay.
Now, if the question is coming from California, we just built a home in Sacramento, and we passed all the Title 24 watt draw tests and duct leakage test. Passed all of it here in the last 2 weeks. And if you're in that market, by all means, it's a Beazer home. We're happy to provide the address. You can go look at it.
Okay. Did have a question from Michael as well. He says, your system reminds me of the Zender ERV HRV system. Do you have plans to add an ERV option in addition to your heating and cooling distribution system to limit the holes in a home to 2 and hopefully make everything even more efficient?
We're very familiar with them. We actually sell Zender some of our component parts for connections. So they use the same duct we do. And so our parts work with their ERV systems. So we sell them some of our components. We have not, on our product development plan, that is not top of mind. That's not to say never, but it's not something we're working on today. We think there's a lot of companies like Zender, April Air, who've got pretty good technology that we would more likely partner with versus developing our own.
Gotcha.
Now, we work with ERVs all over the country, right? The only challenge it creates for us and everybody else is the size of the mechanical room. But for example, in Minneapolis, they're code required. So we've worked with HRVs and ERVs for months or years now.
Right, and as you see the codes getting lower and lower on air changes per hour, you're going to see more of that stuff come in too. So
yeah, that can't happen fast enough in our view.
Right. Yeah, there's some places that drag their feet a little bit more than others, for sure.
Yeah.
Well, we don't have any other questions, so I want to thank you, Alan, for sharing your time with us today and information on this. This has been very helpful. Thank you also to our audience for attending and asking all those wonderful questions. And thank you to Mitsubishi Electric, Westlake Royal Building Products, Schneider Electric, and Beko for their generous sponsorship of the Housing 2.0 program. Now, if you enjoyed today's webinar and you'd like to learn more about Housing 2.0 strategies, such as comfort or maybe design or community or performance, you can register now for the third workshop series of 2022. That 6-part series is going to begin on Thursday, November 3rd at 12 p.m. Eastern Time. Simply go to greenbuildermedia.com/housing-2.0. And you can also join us again on July 20th at 2 p.m. Eastern Time for another webinar in our Thought Leaders series. Those are always free to attend. We'll be looking into the future of housing peer reviews with Jimmy Duffy of the Baca Group. Thank you once again, everyone, for joining us. Thank you, Alan. And until next month, take care, everyone. So long for now.